Morning students. Now today we are going to start properties of integers on addition and subtraction. Very first property of integer is closure property. Closure property of integers under addition. We know that sum of any two integers is always an integer. For any two integers a and b, a plus b is an integer. Here example is taken, 3 plus 5 is equal to 8. Here 3 and 5 both are integers, and the sum of 3 and 5 is also an integer. 3 plus minus 5, here 3 and minus 5 both are integers, and sum of these two integers is minus 2, that also comes under integers. Next, closure property of integers under subtraction. So integers are closed under subtraction means for any two integers a and b, a minus b is also an integer. When we will subtract any two integers, we will obtain the result that will come under integer only. As for example, 8 minus 3 is equal to 5. Here 8 and 3 both are integer, and its subtraction. After subtraction, what we get, that 5 is also an integer. 7 minus 11, both 7 and 11 are integer, and after subtraction minus 4, that also comes under integers. Next, commutative property. So addition of two integers are commutative. For any two integers a and b, a plus b is equal to b plus a. It means if we will change the sequence of integers, then also the result which we will get, that in the earlier stage in which sequence the integers are there, it will be equal to that. For example, you see 3 and 2 integers I have taken as an example. 3 plus 2, it will be 5, and sequence I have changed now here, 2 plus 3, that is also equal to 5. So that's why we can say 3 plus 2 is equal to 2 plus 3. Similarly, another example is cited here, 3 plus minus 5 is equal to minus 3 plus 5. In both the case, if I will calculate it, then I will get minus 2. So we say that subtraction of integers are commutative. Next, here subtraction of integer is not associative. For any two integers a and b, a minus b not equal to b minus a. For example, you see 3 minus 8. 3 minus 8 will be minus 5, and 8 minus 3 is equal to 5. So this minus 5 cannot be equal to 5. That's why we say that subtraction of integers is not commutative. Next, associative property. Addition of integers is associative. We say that for any three integers a, b and c, a plus b under bracket plus c is equal to a plus under bracket b plus c. As for example, here you see 3 plus 5 under bracket and outside the bracket plus 2 is equal to 3 plus under bracket 5 plus 2. Now in this case also addition will be 10, and in this condition also addition will be 10. So we say that as addition of integers is associative, and subtraction of integers is not associative. Subtraction of integers is not associative. For any three integers a, b and c, a minus b minus c, a minus b under bracket minus c not is equal to a minus under bracket b minus c. As for example, 3 minus 5 under bracket minus 2, this will be equal to minus 2 minus 2 is equal to minus 4. If we will simplify this, 3 minus under bracket 5 minus 2, then it will be equal to 0. So here clearly you are seeing that 3 minus 5 under bracket minus 2 is not equal to 3 minus under bracket 5 minus 2. So we say that subtraction of integers is not associative. For what is the utility of these properties? The utility, the benefit of these properties are when we simplify any such type of questions, then in the simplification with the help of associativity or commutativity, our simplification becomes easier. This is the utility, this is the benefit of these properties. Next, additive identity. 0 is called additive identity. Why? Because you see, a plus 0 is equal to 0 plus a is equal to a. A plus 0 is equal to 0 plus a is equal to a. Or some other example you take, 0 plus 5 is equal to 5 plus 0 is equal to 5. So when we add 0 with handy number or with handy number we add 0, in both the case we obtain that particular number only. This 0 does not bring any change in the case of addition with any number. That's why we say additive identity. 0 is additive identity.